I'm Orv, W6BI. Been a ham radio operator since like forever, and pretty much been a digital guy all my ham radio career, starting with Morse code. Worked up through over a decade on RTTY. Got interested in packet radio for a while, then back on HF with, I think, PACTOR and then PSK31. And about 5 years ago, got interested in this ham radio networking stuff. So that's what we're going to talk about today, specifically ham radio networks created with the AREDN software. There are a couple other network schemes, HamWAN and a couple of others, but they're beyond the scope of this discussion, but you can always Google them if you're interested in them. AREDN by now is by far the most popular method of making ham radio networks, principally because it was designed for ease of deployment. And we'll talk about that later. So anyway, helps if you turn on your clicker. So back in the days of packet radio, early packet radio, I don't know, 30 years or so ago, we tried running TCP/IP, the networking protocol, over packet radio. But packet isn't particularly fast, and when you add the 18% overhead of the Ethernet packets, it was just dog slow. I don't know of anybody that still uses it. It kind of worked, but it was just agonizingly slow. That's because packet is 1200 baud, and with the modulation scheme they use there, 1 baud equals 1 bit per second. And in modern terminology, that's 0.0012 megabits per second. It wasn't real fast back then, but we had it, and we used it, and we still use it, and it works very, very well for low-speed data. But you know, time marches on, and now our RF links can be over 100 megabits per second using this equipment. But just like your 56K dial-up modem, that's the modulation rate. That's not the true end-to-end throughput. But because you start so much faster, you end up with a good throughput end-to-end. Back in the early days of ham radio networking, there was a lot of hackery involved in getting going. For better or worse, that's behind us. There's not much required. You can purchase a piece of off-the-shelf equipment and get going with a software update. Back then, it was all Linksys, and I'll shut my phone off. It was all Linksys. Since then, when they moved from broadband hamnet over to the AREDN group, they adopted the Ubiquiti gear, newer gear, more capabilities. Shortly thereafter, they added products from TP-Link. A couple of years ago, Mikrotik gear, and I think last year, GL.iNet equipment. A lot of the gear is very similar in capabilities, but there are a lot of them that are niche products. So there's uses for all of them, and we'll show a few of those. You take this stock access point and you load the AREDN software on it, and poof, it's a ham radio. And we'll talk about what it does to change them. But in the end, it creates a ham radio IP network, the hamnet. I try not to call it mesh networking, although you'll hear me say that occasionally, because of all the things it does for us, the mesh capabilities, turns out that's the one it does the most poorly. There's some significant issues with it, but we'll talk about that. Anyway, as of today, AREDN software supports 4 brands of equipment we talked about, and over 70 different models across all the 4 product lines. Supports 4 ham radio bands, and we'll talk about those. And supports what they call internet tunneling. You know, we've had FM repeaters around on VHF and UHF and other bands for, gosh, what are we doing, about 40 years now? And you can still find spots in the US where there's no repeater coverage. We've only been deploying ham radio networks for about 5 years ago, really, actually, practically, 5 years total. actually about 4 years ago, is when we gained the capability of linking them together well. So it's not unusual for someone who gets into mesh networking to find themselves in an RF hole when it comes to the network. No access points accessible. So they're forced to get on the network via a tunnel. AREDN has modules for a tunnel server and a tunnel client, and you can connect them together over the internet. So you can at least get on the network until there's an RF link from your QTH. The little asterisk at the end is to remind me that you can't natively do it with a node. You have to buy one additional piece of equipment, which we'll talk about, but it's not expensive. So these two are bolded. These two bullets are bolded and together because combined, they make up AREDN's secret sauce. The features that allow it to work so effectively. Back in, I'm a think, mid-2015, they came out with beta code that allowed them to move the radios off of the common Part 15 unlicensed channels to the adjacent Part 97 ham radio only channels, which obviously were much, much quieter. And having a quiet channel greatly increases the signal and noise ratio, as you'd expect. And as a result, the distances we could cover jumped up by about a factor of 10, I think. Additionally, the newer gear is MIMO, multiple input, multiple output, and we'll talk about that and how it enhances throughput. And the 802.11n protocol is ideally suited for long haul connections, and the two of them together work very, very well. We'll talk about them a little more. These are the items that AREDN has included in their software that makes it easy to deploy. There's a DNS server in the software, so anything you connect to it can get an IP address in your shack. DHCP services, or DNS and DHCP. DHCP for IP addresses, DNS for name resolution. They do route broadcasting, so they have route discovery and routing information, so they automatically know the route to remote nodes. All those combined together make it a lot easier to get on the air. So let's talk about these wireless access points. You have to kind of consider them like handy talkies. They're low power, even low power than a handy talkie. Most of them are around 600 milliwatts. A few of them are higher. And because there are 2.4 gigahertz, 3 gigahertz, and 5 gigahertz, they're pretty much line of sight. Strictly line of sight, actually. We'll talk about that more. As a result, you almost always talk to a high-level site. Could be a hilltop, a water tower, a mountaintop. And because of the routing software, even if your node hears multiple nodes, it will always go through the best route. So there's no point in picking an omnidirectional antenna. You might as well focus all your gain in one direction with a directional antenna. The thing on the left is about 10 years old. I'm happy to say that we can go farther than 15 miles now if necessary. That's not optimum network design, but we can do it. But the tree thing still holds. Two's company, tree's a crowd. So, by the way, a knife edge refraction may work in FM communications, but it is not your friend in digital communications. Is somebody mute their phone there? Okay, let's talk about the digital networking bands. 900 megs, 2.4, 3 gigs, and 5 gigs. Now, hams have higher bands, but there's no off-the-shelf equipment for like 10 gigahertz that AREDN supports yet anyway. Excuse me. Excuse me again. The 900 megahertz band does get used, but not much in urban areas because we're secondary in the band. We only have 5 megahertz channel, one 5 megahertz channel to use. and we're secondary to every smart meter that there is, power meters, water meters, gas meters, whatever. So it's a very, very noisy band. But it is used some where it's not noisy. Also cover 2.4 gigahertz, 3 gigs, and 5 gigs. 2.4 gigahertz was the first band where AREDN gained the capability to move out of the Part 15 and down into the lower Part 97 only channels. But there's only one channel down there that's really usable. If you're interested, it's channel -2. And while there's no Part 15 equipment there, it's still quite noisy due to splatter from the adjacent Part 15 channels. So while it works better, it didn't work as much better as they had hoped. So when they gained the capability to go to 5 gigahertz, most people are deploying that now because the band is quieter. There are a lot more ham channels. You get more gain for your buck because same size dish has more gain at 5 gigahertz, obviously. And the gear is not any more expensive than the 2 gig gear. 3 gigahertz is a Part 97 band. They took the Part 15 stuff away quite a few years ago. That's the good news. It's all ours. The bad news is they don't make any domestic equipment for it, so you have to buy international gear. It's fairly scarce and it's gotten fairly expensive. But it works very, very well when you can get it. Wouldn't recommend it for end user use, but we do use it for backbones here and there. The little asterisk next to it is to remind me to tell you that the FCC wants to take it away from us. It looked pretty bad, but the Department of Transportation is pushing back very hard on the FCC because the FCC said they could use it for vehicle-to-vehicle communications a number of years ago. And all this time, DOT's been working at defining protocols and messaging and stuff like that for the domestic car manufacturers. Now, DOT's really upset that all that work's going to go in the toilet if they're not allowed to use it. So we may be able to save that band. We'll see. The asterisk behind the 5 gigahertz band is because the FCC is proposing converting our Part 97 channels to Part 15. Well, that's not good news. They won't take the channels away from us, but as those channels get more and more populated by non-ham transmitters, it will get more noisy and we'll have to have more link margin, stronger signals to maintain our signal and noise ratios. So you put all this good stuff up on the hilltops, you build networks and stuff, but just like the internet, you don't use the internet. You just use it to get places. AREDN calls them services, things you can actually use. All of, I've put a few things up there can use, but actually anything with an IP address that you can hang off an Ethernet cable, you can put on the ham radio network, subject to the regulations in Part 97. We'll talk about a few of these. I'm going to discuss applications that we have used locally here in Southern California. We may not use all of them everywhere, but I'll at least give you a sampling of what they have, what's available. Keyboard to keyboard is used a lot. One of the popular applications is called Mesh Chat. And it runs on a Raspberry Pi. And you can create multiple channels so you can go off and talk privately. It will find other Mesh Chat servers and sync up with them. That's a good thing if you've got, I don't know, half a dozen of them spread across, 100 square miles. You can connect to the closest one and talk with other people. It has a web-based interface, so there's no application to install. And it has a built-in Dropbox for file storage. You can upload a file and anyone else can download it. Here's a annotated screenshot done by Trevor, K7FPV, who actually wrote Mesh Chat. He's got all the notifications there. You type down in the bottom, you type message in where it says new message, you hit enter, and it displays down at the bottom. We don't use it too much around here. We've in Southern California. all my bias here is to Southern California because that's where I live. But We don't use it too much anymore. We've moved on to something different. People like it. The only knock against it, and I guess it depends on your network, is I've heard that it can take a significant number of seconds for messages to appear on remote mesh chat servers due to the syncing and the network traffic. But I have no experience. I've just heard that. So we moved on to something called Mattermost. If you ever use Slack at work, it's very, very simple. Mattermost is the kind of the open source equivalent of it. It supports text, obviously, like the old IRC, which is still even used a little bit, but it also supports images, which adds a nice dimension. And as usual, multiple channels are available. The nice thing about it is, and I'll talk about this a little bit more, in addition to web access, there's applications for pretty much every OS. I have it on my Android phone. And my actually have it on my Linux computer too. Here's a screenshot of an old chat I had here. Eric, KG6WXC, who maintains this Mattermost server, likes to go camping with his wife and daughter out in the desert. And they've got some land out there. They happened to be camping out there near Ridgecrest when the 7.1 earthquake hit. And they got quite a bit rock and rolling around them. The next morning, he drove over to where the rupture in the ground was and took this photo. The reason we see it here is he runs a Mattermost server on the internet linked to a Mattermost server on the mesh network, and I'll talk about that a little bit more. So he was able to take this picture and show it to us on the mesh network, which is really kind of handy because if you've got it on your phone, you can keep in touch wherever you go with your mesh networking friends. Again, this is specific to Southern California, sort of. We have two Mattermost servers in Southern California. The KG6WXC one is in Ventura County. KK6ORT is down in Redlands. I'm not sure if that's in Orange County or farther south, but they are linked together on the mesh network. On the internet, we have the mattermost.kg6wxc.net. So it's available from the internet, and all three of those are linked together. So it's kind of a nice way to keep in touch. If you're in Southern California and you can hit either one of those Mattermost servers, you're welcome to log in. For the internet one, in order to confirm you're a ham radio operator, you need an invite from any existing member. That could be me or Eric, kg6wxc@gmail.com. But you can ask me, and I'll just pop over here to the Mattermost client and send you an invite. I think we have about 80 users now total. So let's talk about voice, VoIP, voice over IP. Most people associate it with phones, but that's not just what you can do with it. Anyway, this photo's about 5 years old now, before we deployed a VoIP server, VoIP PBX. The old Cisco phone used for testing on the left, got it on eBay for, I don't know, 35 bucks. There's a lot of open source software to support VoIP PBXs, Asterisk, Free PBX, RAS PBX, but at the time, the ham who was deploying VoIP wasn't familiar with Linux and decided to buy a turnkey system. He bought this PBX from Grandstream. It's 250 bucks or something, but has some very nice administration menus, so you don't have to get down in the weeds of Linux. So this is prior to deployment, and this is after deployment. This is in the Pleasant Valley Amateur Radio Club building on top of Sulphur Mountain, which is south of Ojai, California. A number of voice repeaters, number of mesh, couple of mesh access points and backbone nodes, but you can see the PBX there. I think at this point we have approaching 30 extensions. Most of them are end users, but we do deploy a VoIP phone to every EOC or every hospital or other emergency department, emergency support group. County EMS has one. And it carries a lot of traffic, a lot more than I would have expected. So here, because we have a Grandstream PBX, we tend to recommend Grandstream phones because you can push new software out to them. Here's a shot of my phone. Somebody called me, I missed the call, and they left me a voicemail. So it's kind of slick. It rings a lot more often than I would have thought. And it has a distinctive ringtone assigned to it. And my wife will tell me my bat phone is ringing. So here's the other PBX we're getting ready to deploy. I mean, it's a Raspberry Pi 3. We're running a free PBX. It's out there on an interim basis, and as soon as we can get up to the mountaintop, we'll move it up there. Administering VoIP PBXs or any kind of PBX is a whole new skill set. So I'm going to have some learning or find a VoIP admin. So collaboration servers. You've probably seen in the movies or TV, the gamers, they have their teams together and they're communicating with headsets. Well, they use a collaboration server to coordinate their movements. We have them on the mesh net also. And typical features they offer are like voice and video chat, file sharing and desktop sharing, and I'm sure there's other features. We've settled on Teamtalk. There's other ones called TeamSpeak. I think there's Mumble, and I saw a list of like 20 different versions. Some are for pay, some are open source, some are proprietary. We picked Teamtalk because it's one of the few of them that doesn't encrypt voice. So we just avoided that whole encryption discussion when we went with Teamtalk, and it works pretty well. The features, it has, as you'd expect, chat rooms, many to many, with a bunch of people in there chatting. Also supports one-on-one chats. You can do that via going off to a separate channel. You can give a person authority to set up an ad hoc channel just for now, or we have some that are there for anybody to use. You can use a speaker and a microphone, whatever's built into your laptop, or you can use a headset, and the headset generally provides much better voice quality because the microphone's much closer to your mouth. Unlike FM repeaters, these are full duplex conversations, which means you can interrupt the person talking. You don't have to wait for him to time out the repeater. And typically, the voice quality is far higher than the communications grade bandwidth 300 to 3000 hertz that we're allowed to use on ham radio. Typically, if two guys have headsets on and the links are good, the audio is just excellent. It's like the guy you're talking to is in the same room. Very high clarity. And for those of us whose hearing isn't quite as good as it used to be, it's just a pleasure to talk to somebody like this. This is not your father's FM repeater. It features push-to-talk, Vox, or open mic. Typically on Windows we use left alt, but it could be any key that's available. Also has Vox. During our weekly nets, I'll put on a headset, close the office doors, put my feet up on the desk, turn on Vox, and just yak. It's really easy, painless. It also has open mic, where you nail up a connection. You might go off on a private channel and two clients connect together there. Doesn't use as much bandwidth as you'd think. In watching a typical conversation is about 30 kilobits per second, which is nothing. I can think of scenarios where you might want to use this if you've got an incident going on with a lot of voice communications between two sites and you don't want to hassle picking up a phone and dialing every minute. You put a laptop in a quiet room at each end, open up the mic, and anyone who wants to talk comes up and says, "Hey, where's Bill? I need to talk to him." And the other end says, "Hang on a second, I'll go get him." Things like that. In the voice industry, they call that a nailed up connection. So here's a screenshot of the Teamtalk Weekly Net. I This is a couple weeks old, I think. You can see the people who are logged in there, name and call sign. When a person is talking, their call sign is highlighted in green. When they're done talking, it turns to yellow. That means the yellow is the person who last spoke, or last keyed up anyway. Down at the bottom, you can see a couple auxiliary channels I created. You can call them whatever you want, and you can make as many of them as you want. If you wanted to talk to somebody and there were 30 people in the main channel, and you wanted to talk to somebody privately, you would both double click on one of the channels down at the bottom. You would be swung over there, and you could chat as long as you want. When you were done, you double click on the main channel and you're back there. And those can be simultaneous conversations. Somebody's got their mic open. Could they mute, please? Up on the top, you can see 4 tabs: chat, video, desktops, and files. This one happens to be the chat channel there, and you can see various, typed asides. You can also use it for video. I don't think video adds a lot in most cases, but it's a lot of fun to use. And this is an excellent way to stress the server and stress the network to tell if everything's working properly. When you're using voice, your 30 kilobit stream goes up to the server and it goes back out to everybody who's logged in. When you're using video like this, in this particular case, there's 1, 2, 3, 4, 5, 6, 7 video streams going up and 7 video streams coming back down, or at least 6. Excuse me. But typically, you configure your video camera for like 320 by 480, or I don't know, 640 by 480 or less, and 10 to 15 frames per second, and it keeps the occupied bandwidth down. I think I checked during this one, and the video stream in and out of the server was about 3 megabits per second, and it handled this pretty well. So it's a lot of fun. I think 7 or 8 video streams is the maximum we've had. And you can adjust the limitations in the server for how much you can allow in and out. And by the way, this server runs on a Raspberry Pi 3, and when this particular session was going on, I looked at the server, and it was at 10% bandwidth utilization and 10% CPU utilization. So a Raspberry Pi works great for a server. They do have software for running the server on Raspberry Pi, a couple of Linux distributions, Windows, and they have clients for Mac, iOS, Windows, Linux, and a couple of others. So it's a lot of fun. We have a weekly net every Wednesday night, and the attendance has been growing steadily. The other thing you do with video is webcams. There's an interesting backstory on this picture, so I'm going to talk about it a little bit. Back in 2017, we were busily rolling out network equipment, getting sites linked together, throwing stuff up just to build a network out, because we'd only been able to have real networking for, I don't know, 18 months, maybe 24 months prior to that. And in a couple of places where we had, and the fire was approaching, it hasn't quite crested the hill here, we were able to stream for about 2 hours. And at that point in time, we lost an intermediate link, lost its power due to the wind. And at that point in time, we had no backup power there. After the link went down and we lost the camera, the fire came across that hill there, proceeded right to left, just in front of the tower, about 100 yards north, and proceeded west and wiped out half of the town of Ventura. About 4 days after that, I got an email from a VCFD, Ventura County Fire Department fire inspector, asking for the URL. I gave it to him and he thanked me, and I never heard anything back, but we did hear later that they found the link useful, the video useful, because it was the first video anybody had of the fire, and I guess it helped them with their analysis. The following June, when the county supervisors declared June Amateur Radio Month like they do every year, in their proclamation, they specifically mentioned the fire and this video. So we got a lot of good press out of it, and it turned out to be really useful. The lessons we learned from this: battery backups everywhere, and we're working on that. Solar power where you can. Pan tilt zoom cameras everywhere when you can afford it, and we're continuing to push those out. One thing with this site has AC power, battery, and solar. We lost AC about 12 hours into it. We lost the battery backup about 12 hours later because the solar panels were covered from ash. They're covered with ash from the fire. So you do what you can. So this was in December 2017, and the subsequent year we actively working at making the network a little more robust. And 11 months later, we have the Woolsey fire. This fire broke out kind of near the border between LA and Ventura County. And during the Santa Anas, the winds blow kind of from the west-northwest, hot and dry. And this fire broke out off to the left of the screen a couple of miles, just south of my town of Simi Valley. And here you can see it threatening the southwest corner. This is from a pan-tilt zoom camera we had installed a few months earlier on the north edge of town. So I zoomed in, you can see this, and you can see it working its way down towards the houses there. County Fire Department made a stand there, fought it off. That fire subsequently turned south, moved away from the camera view here, proceeded south, and burned its way through Thousand Oaks. So we lost more that way. But again, we streamed this video, and the number of people watching it was even higher. So you can also do plain old email. Plain old email uses SMTP, standard messaging transfer protocol, or something like that. So pretty much anything can work. Clients like Thunderbird, web clients, Route and Cube is one of them. RMS Express, Outpost, and WinLink, they all use SMTP for mail forwarding. So you can move messages around. And there's a, there's a BBS package that I'll talk about. So I just put this screen up here. I don't run WinLink. I need to learn. But we had a number of WinLink users in Ventura County. It's not as widely used here as in elsewhere, but they do use it. And we use both 2 meters and 220 for packet forwarding. We took a couple of the users, WinLink users, and swung their WinLink stations over to mesh networking and had them test it. And their comment was, wow, does it move traffic fast? Pretty much as you'd expect. So we're starting to see an uptake in people adapting rolling mesh connections into their WinLink where they can. Dan, KE6NYT, who's big into packet and WinLink here, but not into mesh, decided to figure out how to add mesh capabilities to his system. This is what he came up with. Raspberry Pi down at the bottom with 2 Raspberry Pi TNCs on top. I'm not going to go over this a lot because I don't know it. Dan address is up there, and he's also KE6NYT at ARRL.net if you want more information. He had a buddy print a 3D enclosure for it, so it came out real slick. He gave me this drawing. I added the red lines. I don't think they add much to it, but it tells you how you get more opportunities for connectivity out of your WinLink system. You can see the mesh network in the middle, and everything on the left is one station, and everything on the right is another station. He built 2 of them for testing. Citadel, if you remember in the old days of dial-up DOS, had BBSs, dial-up BBSs, and they were pretty full-featured. Well, if you roll forward 25 years, they're still around. They've been webified, but they still offer mail, calendar, contacts, notes, all those things on the left. And if you had a group of mesh users who were working very closely together on a project, you could give them one of these BBS servers, and they could keep their notes here, their contacts, a chat room. They could stay online all the time. This runs on a Raspberry Pi very nicely. It's easy to install and deploy. We rolled one out, we tested it, it works fine. Don't need it at the moment, but we could roll one out at a moment's notice. Other stuff. Once you convert analog to digital, the sky's the limit. And if you have two analog repeaters remotely located, you can link them over the mesh network. If they're DMR, D-Star, and All-Star, obviously that's a no-brainer. I don't run any of those protocols, so don't ask me any questions about it, but there are more and more people out there who are doing it. Also, you could buy a couple of these devices from either SkyMira or JPS and slap them on an analog repeater as shown there and just link them across the mesh network and you're up and running. You can buy used on eBay a lot cheaper than you could put together like a 420 repeater for each end for linking. Other stuff you can put on the network, if you have a weather station, this is mine. This is the plain vanilla web interface of WeWX. It's at wewx.com, WEEWX.com. It's open source software, runs on about every OS ever invented, supports just about every weather station or sensor ever invented. So if you have a weather station, you can put it out on the meshnet. I mirror mine out on the internet too, so I can see it wherever I go. And there's also a view. WeWX also provides a view that's not a standard web, but it's based on the screen coverage on a smartphone. So I pull that up on my phone. It's good software. Being open source, it's highly configurable. This is the stock display, but you can go crazy with the UI. And I just took this screenshot of somebody who obviously went crazy. I don't know if I'd put that much effort into it, but somebody obviously had fun customizing the user interface. It's not all about the emergencies. We have a Scrabble server on the network someplace. We have a tank game called BZ Flag. You can shoot them up with other tanks. And sometimes after the Wednesday night net, we have play a couple of hands of Texas Hold'em. I suck at poker, but it's still a lot of fun. Eric KG6WXC wrote a mesh mapping program. It goes out and dynamically pulls all of the nodes, crawls the network actually, and there's a file on each node containing all its vital data. And he pulls that all down and puts it in a database. That's very, very handy. You can click on any one of those nodes shown on that map. It'll pull up a little pop-up that shows you call sign, latitude, longitude, what the hardware is, what the software is, bearing and direction to whatever links it has, and the link quality. Very handy. And the software is open source. Anybody can run it. And if you have a lot of nodes in your neighborhood, I recommend setting up one of these mappers because back in my days as IT management, we said you can't manage what you can't measure. So it's really great for keeping track of who's not keeping up on their software upgrades, who needs to maybe align their antenna a little better, stuff like that. So anyway, so I took some screenshots of some mesh mappers running out there. This is Salem. Orange is 5 gigs, purple is 2 gigs. The pink is 900 megs, so they are running some. And the blue is 3 gigs, so they have the whole gamut there. And you'll notice a few that are gray. Those are nodes that don't have any RF output. And you might wonder, why the heck would you want to do that? We'll talk about that in a little bit. Here's Yakima, Washington. Chad's done a good job of deploying stuff out there. They have a lot of 2 gig and some 5 gig. This is San Francisco. This is SFWEM, San Francisco Wireless Emergency Matrix. I don't know. This is kind of near and dear to my heart. I gave a presentation at Pacificon in the Bay Area, East Bay, last October. And at that point in time, they had nothing going. After my presentation, a few of the guys cornered me out in the hallway and picked my brains for 45 minutes or so. In the subsequent months, actually in the last 6 months, this is what they've rolled out. They've done a great job of rolling out stuff, and a lot of these are at fire stations and stuff like that. So they're getting up to speed and very well prepared. And this is the big gorilla, 800-pound gorilla in the room. Southern California. Because we have a couple developers, ardent developers in this area, we kind of got a head start. And as you can see, there's a little of everything there, including tunnels all over the place. The gray lines are the tunnels. The one going off to the lower left goes to Hawaii, of all places. In this view here, there are about 425 nodes, both ground level and hilltop. So we've got quite a few. I think the other day we hit our high water mark of nodes at 581. I have no idea. A lot of those are coming through tunnels, not locally. So I go by the 425 physical nodes local when I tell people about our network locally. So you want to get on? You need some equipment. What's out there? Here's what you can get. Like I said, 4 bands. They're designed for outdoor use. They're weatherproof, and they have PoE, power over Ethernet, so you only have to string one cable up that carries both power and data. Not one, but 2 very sophisticated transceivers inside there. Transmitter receiver, digital, software-based digital modem, CPU, RAM, ROM, Ethernet interface, power, PoE interface, and there's 2 of them in there. They use 2 for MIMO. We'll talk about it even more. So if you have 2 transceivers, you need 2 antennas. And all of the gear that I'm going to talk about that's suitable for the home use has built-in antennas. There's 2 of them, one vertically polarized and one horizontally polarized, both gain antennas, each one driven by a transceiver. So there's 2 data streams going to the other end. What it does, it splits the data coming in into 2 streams and recombines them at the other end on the same frequency, one polarized vertically, one polarized horizontally. I don't know, I think there may be some magic involved. By the way, if you ever want to get a headache, go skim the article on 802.11n in Wikipedia. You don't have to read it all, but look at the high points. It's amazing the technology and the sophistication they pack into these little boxes. And as you'd expect, being able to send 2 data streams allows you to put a lot more data through these devices. When we first got started, I was overjoyed to get a megabit per second end to end up to a node and back. The maximum we've gotten recently is 19 megabits per second. And now that's just point to point, but still way better. Okay, if you're thinking about buying used equipment, be wary. The older generations had 32 megabytes of RAM and 8 megabytes of ROM, which is actually one of the limiting versions. AREDN's based on OpenWRT, the access point software, open source access point software. And as it grows slowly larger, AREDN grows slowly larger. They've managed to fit the production releases into these 32 megabyte devices, but it's tight. There's no guarantee that future versions will fit. And the older devices have slower CPUs in them too, and they're typically not MIMO. You don't see it much, but it's SISO, single input, single output. They don't perform as well compared to the MIMO, and they don't mix well with them either. You can pass data, but it's not optimum. So this is old school. This is how you got on the air, I don't know, 8 or 10 years ago, not waterproofed. And in spite of having 2 antenna connectors on the back, it was not MIMO. I think it had 4 megs of RAM. And I mentioned that the modern equipment has 600 milliwatts of output. This has 60. So you're 10 dB down right there. And is not capable of moving out of the Part 15 band. So a lot of guys have piles of these laying around, and I tell them use them to prop a door open. That's really all they're good for anymore. You could use one as a wireless access point on your ham radio network in your shack, but there's slicker ways to do it, and we'll talk about that. So the next generation was this here is typical. Ubiquiti Bullet, 600 milliwatts, only one antenna output, only 32 megs of RAM, and it's not MIMO because it only has that one antenna connection. So if you have any of these on the air, think about retiring them. So the next generation typically is the Ubiquiti Nano Station for 2 gigs and 5 gigs, and TP-Link has some equivalents, and I will talk about them too. About 3 years ago now, the 5 gigahertz was upgraded from the older XM hardware platform, which is 32 megs of RAM, to the XW platform, which is 64 megs. And about a year and a half ago, the M2 got the same transformation. But they typically don't tell you when you're buying them whether the old or new. There may still be new in stock available, so be careful. They'll run, but if they're 32 megabit devices, the future is uncertain. But the other reason they're popular, you can see down at the bottom on the right, the cutout in the cover for the Ethernet cable. And if you look very closely, you can see to the right of that, there's a spot for another cutout if you take it out with a pair of pliers or side cutters. That's because the Nano Station here from Ubiquiti and the TP-Link equivalents are the only devices that have 2 Ethernet ports. They have a main port, which is input, and a secondary port, which is output. And we'll talk about why that's really, really handy. So these are your go-to devices for the most part. Ubiquiti Power Beam dishes and the Mikrotik large head grid 5 and 5XL. The XL, as you'd expect from the name, is larger than the 5. They also make an HP version, which I think is 3 dB higher in power. I gotta look that up. And the Power Beam, if you look in the middle, that's the entire radio at the feed point. Transmitters, receivers, modems, little antenna to illuminate the dish, but they're identical in all of the 3 models. There's 3 models, 300 millimeter, 400, and 620. 620 is really large. I think your neighbors would have concerns if you put that up, but they have, as you'd expect, consecutively higher gains. With the higher gains come obviously narrower beam widths. I think the 400 is under 10 degree beam width. So you really have to be careful and precise in aiming them. Excuse me. Fortunately, AREDN has recently added some aiming utility in the software, both visually and audibly, which makes it considerably easier to line them up. This is an interesting piece of equipment from Mikrotik. It's a light dish feed. This is the 5 gigahertz version. There is a 2 gigahertz version available. It's about the size of a softball and only has a 9 dB gain. So why would you want that? Well, if you live in an HOA, they're severely restricted antennas, but they do allow satellite antennas, satellite dishes. So what you do is you buy one of these LDFs and an $8 universal mount, and you slap it at the feed point, you put it up, and nobody's going to notice that it's not pointed up at a satellite in the sky, but at a hilltop someplace around. They work very, very well. I think on 5 gigahertz, typically you get 23 dB gain out of this. So a nice workaround. And typically you can get surplus satellite dishes for nothing. People are happy to get rid of them. And here's another one. Damon, K9CQB, sent me this photo. I didn't know they made portable satellite dishes for RVs, but it makes sense. Not particularly cheap, but it's very portable. That dish folds in half. So I thought that was pretty slick. Here's the TP-Link. On the left is the Nano Station equivalent, the CPE 210, 220, and 510 for 5 gigahertz. and on the right, the CPE 610 for 5 gigahertz. From the get-go, TP-Link has all been 64 megabit devices, so they're holding their age very, very well. I don't know if they make the CPE 210 anymore. I think the 220 has superseded it, but I have a 210 version 1 that's got to be 6 years old now, and it's still up on the air, still running, taking all the newer software updates. I'll probably run it till it drops dead. So they've never been super popular compared to the TP-Link, but they're gaining in popularity. Up in the Bay Area, they use them a lot. So what else do you need to get going besides that? If you've ever left a piece of standard Ethernet cable outdoors in the sunshine for a few months, you'll know that it doesn't do well with UV. It tends to crumble badly. So they recommend outdoor Ethernet cable. Sometimes they call it direct burial. Ubiquiti recommends shielded, and if you're in an area of the country that's prone to lightning storms or on any hilltop, you'd want to do that. Places where the weather's a lot more benign, like here in Southern California, I would say shielded is optional. I don't put shielded cable up on my tower, and I've never had an issue, he said, knock on wood. And it's much easier to deal with if it's not shielded. It's quite stiff. You need a dedicated computer for the mesh network because it's a standalone network on 10.0.0.0. It won't link to your home network. That a little asterisk is for me to tell you, however, there is a neat little workaround, and I'll talk about that. Prior to this, it was a real pain to have to run two computers. So a little show and tell here, a couple of typical home deployments. This is K1GGS. Why would he have 2 nanostations? Because the site he's aiming at has user access points for 2 gig and 5 gig. And if one of those goes down, he still has network connectivity. We're doing this at all the EOCs, PDs, and other emergency groups that we deploy to. If they have line of sight to a site with either 2 different bands of access, or they can visually line of sight see 2 different sites, we will put 2 nodes up there and point them at the appropriate hilltops so they have some redundancy. It's not expensive. So here's another one. This is Richard, KM6PTE. It's hard to see here, but his Ethernet cable goes up into the nanostation, into the main, forwards data and PoE power out the secondary, powering his light head grid, his Mikrotik LHG5. So this way you can have 2 nodes pointing 2 different directions or whatever on the same mast, but only have to run 1 Ethernet cable up there. All the stuff I've shown you previously is intended for home use, and for the most part is not appropriate for hilltop, just like you wouldn't put a Baofeng handy talkie up for use at a repeater site. What you're looking at here is a sector antenna. It's called that because it's designed to cover a sector or a section of the compass. This one's probably 120 degrees from Ubiquiti, which this is made by. You can buy, I think, 90s and 120s. Third parties, you can get 60s and 180s. And the neat part about it is there's 2 sector antennas in there, one vertically polarized and one horizontally polarized. And on the back of it, you can see one of the 2 SMA connectors with a jumper going to the top of the Rocket, Ubiquiti Rocket 5 gig node. By doing this, you can adapt the coverage on a hilltop to where your main body of users typically are. And if you have 2 bodies of users that are 180 degrees apart, you might think you'd want to use an omnidirectional. But if you do that, you wind up with the hidden terminal problems we had in Packet. A better solution would be to put 2 sector antennas up there pointing at your 2 user communities on different channels and tie them together with an Ethernet switch down at the ground. That's almost universally done now. Oh, by the way, all of the stuff I've talked about previously, typically the price of 3 Baofeng handy talkies, something like that, a little bit more for the coax or Ethernet cable. What you're looking at here on the screen is about $275. And if you talk about two of them pointing at two user communities, plus a dish for your backbone going to another hilltop, plus the tough switch down at the bottom, or edge switch from Ubiquiti, tying them all together, plus batteries, plus power supply, you're talking about almost as much expense as running a complicated repeater site. So just like a lot of people band together to support their local repeater systems, you might think about joining up to support the build out of your local AREDN mesh network if you haven't already done it. We've done that here. Because if you put 3 or 4 of these on one site and then you've got 6 or 8 sites you have to deploy, that's a lot of money out of 1 or 2 person's pockets. Okay, some typical hilltop sites. This is your, I call it, it's small physically, but since this photo was taken, they've added a 3rd sector antenna. This one's strictly solar and battery because it's a quarter-mile hike from the nearest dirt road. The batteries and solar panels are behind us from the viewpoint of this photo. He's got a camera looking at the batteries and the solar panels. I asked him why. He said, well, I don't have a weather station up there, but the camera there is focused on a clock type thermometer, so I know how hot it is up there. Poor man's weather station. He's also got a pan-tilt zoom camera at the top. This is on a hill on North Orange County, and I think you can see John Wayne Airport off to the left there, maybe. I don't know. It's in that general area. So here's a larger site. This is on the border between Ventura County and LA County. Container down at the left has the repeaters. You can see the 4-pole at top for the UHF repeater, plus a 420 Yagi for the link going to the other sites. On top of the tower is an Omni for the VHF repeater. Below that, a pan-tilt zoom camera. And 1, 2, 3, 4 sector antennas. Lower left sector antennas, a part 15 access, which is not used anymore. Bottom sector antennas, 5 gigahertz user access for the east side of our valley. Upper right is 2 gigahertz user access for the valley. Upper left is a sector antenna on 3 gigahertz, which we use to tie together the 3 sites in the valley for a kind of a local backbone. The big dish is the link westward to the rest of the county backbone, and the little dish was for a test network and it's not used anymore. Okay, you can't see it, but there's a set of stairs behind the rocks here, and buried next to the rocks are conduit with some Ethernet cables. They go up to a site higher up on the site, which has a bunch of other ham radio stuff. And one of the things that it has is a 3 gigahertz dish linked to this system pointing east. That hits the 3 gigahertz dish on the corner here looking at us. This is the darn site, Disaster Area Radio Network, I think. They're a repeater system in Southern California, of which we have lots. Darn has, I think the last time I looked, 46 repeaters on 26 sites. And linking a lot of them, they have their own microwave system. A lot of it's Ubiquiti gear, and they were kind enough to let us piggyback on their microwave to carry our backbone over to this site. And on this site, you can see up at top 3 sector antennas, which are user access points for providing coverage for the San Fernando Valley. There's a lot of other stuff there. One of the dishes on the telephone pole pointing to, actually both of those dishes point to 2 of their sites off to the east. One is Mount Wilson above LA, and I don't know where the other one goes. We came up to do a site survey after a windstorm. That's when I took this photo, and you can see that their HF vertical for the remote base suffered badly. It actually snapped a U-bolt, I think. It's since been repaired. And just as another aside, you notice how the top of the telephone pole is a little stubby and broken off? It got burned off on a brush fire that burned through there about 10 years ago. Did a lot of damage. So here's what you could call your large site. It's probably one of the largest sites around. This is a commercial installation on Pleasants Peak. I think it's South Orange County. The owner is ham friendly, and as a result, Joe AE6XE, who happens to be one of the AREDN developers, has populated it over the years with all the stuff that's highlighted in yellow. So he has very, very good coverage. Not shown in this photo because it's down below. There are now 4 dish antennas pointing at different parts of the compass, making this a main hub for the mesh network in Southern California. So you can see there's a lot of expense and effort that goes into maintaining one of these as it grows. Okay, I'm going to show a few screenshots of the AREDN node interface. I'm not going to go into it in great detail because I think I'm going to do another presentation focused on all the nooks and crannies of the interface because they've added a lot of features over the last 5 years. This is the main web interface to a node. There's all sorts of information here. I'm not going to go through it. All sorts of vital data. There's a button there called Mesh Status, and this is what you get when you see that. And of principal interest, there's 2 columns. The one on the right, labeled Current Neighbors, are all of your direct RF links. Yeah, and down below there's some other stuff that are direct wired links. And we'll talk about that column in a minute. On the left are remote nodes. Those are nodes that are more than 1 hop away. This is the right-hand column, zoomed in some. Everything that's underlined is a URL. You can click on it and go there. Jussi is AA6KJ. You can see he's offered services in AREDN Mirror, which is, I guess he pulls down all the nightly builds and puts them there if you need them. He mirrors the DX cluster, got some other stuff there. The 3 columns at the top are LQ, NLQ, and TX MBPS. And by the way, this screenshot is from the hilltop looking down at him, looking down at all these hams. Link quality is how well the hilltop is hearing him. Neighbor link quality is how well AA6KJ is hearing this station, the hilltop. And TX Mbps, transmit megabits per second, is the modulation rate, and I learned times the actual packet success rate. If you had, for example, a modulation rate set up that was 50 megabits per second, and you're getting 90% of the packets, it would show 45 here. So anyway, that's the current neighbors. Now on the left-hand column are local or remote nodes. These are more than 1 hop away. And there's no RF measurements here because these aren't RF linked, not direct RF links, but there's something called ETX. And that means approximately the number of packets you have to transmit to get one through. And personally, I would cut the ETX off at about 20, but AREDN has the default set to 50, which is kind of silly because you can't get to anything where you have to transmit 50 packets to get one through. As a rule of thumb, if you run video, your ETX has to be greater than 4. I'd say voice greater than or less than 4, and less than 2 for voice, and text. No, I went the wrong way. Less than 4 for video, maybe less than 6 for voice, and for text, you know, pretty much anything will get through. So all of those things are URLs, so I got tired of clicking on them, so I made a couple folders and just bookmarked everything and named it the way I'd want it because I do admin a lot of stuff. Just an example of what you might do. So if you buy one of these things, what do you get? You get the node. It becomes a node when you load the AREDN software on your access point. And you get the PoE injector and the AC power cord for it. The cable from your computer, Ethernet cable, goes in one port, and the data from your computer and the 24 volts from the PoE injector go up the outdoor rated cable to your node. That's great, but this has got to be a dedicated computer. There's better ways to do it. With one of these things. This is made by Mikrotik. They call it their HAP AC Light Router. when you put AREDN software, it becomes a node with all sorts of capabilities. I suck at graphics. A ham was kind enough to do this up for me. With the AREDN software on there, it has a 24-volt power supply going in. You can turn on PoE going out port 5, so it's a node-to-node connection over a DTD connection, device to device. That's the protocol running over a wire. Because the Mikrotik becomes a node, it'll show up on the network. By plugging a cable into your home network router on WAN 1, port 1, everything plugged into ports 2, 3, and 4 there has access not only to your home network and out to the internet, but also out to the mesh network through port 5. So this is very, very versatile. In addition, the HAP has 2 internal radios for 2 gig and 5 gig. The 2 gig can be set up as a mesh node if you want, but the internal antenna is really inefficient, so there's really not much use to run it as an AREDN node. So you can set it up as a 2 gig Wi-Fi access port and connect your smartphone or your laptop to it wirelessly. Very handy. The 5 gigahertz radio will not do AREDN mesh, but it will operate as an access client. And by the way, access point. And they recently added software in there. You could convert them both to access clients. Why would you want to do that? If you're traveling, you take one with you. And if you're in a hotel where you have to pay for each individual hookup to their Wi-Fi network, you set one of these up as an access client, connect to the hotel's access point, and you hook everything you want up to your own access point here in the HAP router. It's very handy. This is pretty much the second piece of equipment every ham buys who gets into mesh networking. It's just so darn useful. So, how do you tell if your site can see a site around you? Well, first you use one of the maps or you ask around. Then you use an online line of sight calculator. There are various ones out there. If you Google searched line of sight calculator or microwave link calculator, you'll find a whole bunch of them. Here's a couple, 3 here. I use hey, what's that for quick and dirty feasibilities, and they all work pretty well. So where do you get information on getting started? AREDN, obviously. Amateur Radio Emergency Data Network, they're ardenmesh.org, not arden.org anymore, ardenmesh.org. And there you can find all the software downloads. And by the way, in addition to the production builds that they release about annually, in between they release nightly builds that have fixes and enhancements to them. And 99% of the time they're very stable and they fix things. Typically they'll release a nightly build to fix a specific issue, and it won't be for anything you're using. But I recommend everybody do nightly builds and upgrade to them every few months or something just to keep up. I don't run the production build much of anywhere because I like the new features and it's good for them to test. How-tos, there are a number of how do you do things. Frequently asked questions, the stuff you'd expect. In the last year and a half, Steve, KC0EUW has rolled out a set of online documentation that is just excellent. It's open sourced, anybody can contribute to it, and it's very, very readable and very, very extensive. I would say even if you're thinking about getting started and you've got your Amazon order coming, look through the documentation. It shows you in great detail how to install the software on all of the different brands, how to configure it, lots of other good stuff. Very recommended. They also have forums, close to 3,000 members now on various topics, and you can skim those and you can post a question there. Unofficially, there is a Facebook AREDN group. It's quite active, about 1,100 members. There's mailing lists all over the place. I know Yakima has one. Also, I run one here for SoCal hamnet users. It's intended for Southern California, but there's general information there. It's on groups.io, SoCal-hamnet-users, if you want to subscribe. There's about 160 users now. It's low volume, no spam. And I also have a beginner's guide as a PDF. Covers a lot of the same material here. And if you need it, just email me at w6bi@arrl.net and I'll send you a copy. There's also one up in the files area on Facebook. I keep that updated too. Oh, and one up on groups.io also. I need to update that one. So, questions, demos? Let me get out of this. You can start up the voice, I guess.
Hi.
Hi.
Can you hear me? This is Dave
Yes.
in Minneapolis. When you're ordering, hi, nice to meet you. Some of the equipment, you have to be careful about getting, say, the international version and make sure that the unit's not locked down to non-amateur radio frequencies.
No, that lockdown is specific to the AirOS software. Once you override it with AREDN, there's no difference between international and domestic.
Okay, great. Thank you.
You're welcome. Any questions? Anybody want to see anything cool demoed? Let me, you still see my screen? I think you can.
Yes, we do.
Yeah, KC0BBK here with a quick one.
Go ahead.
Yeah, I mentioned it yesterday, and I thought I'd get it on here since this is the recorded version. It's going to be published in the Twin Cities, Minneapolis, St. Paul. Dave, the person who was just on here, and myself, KC0BBK, have got 14 node network running here in the Twin Cities. So if there's any hams interested that are looking at this, just give us a call and or give us contact, and we'll get you into our network.
That's good to know.
Thanks, appreciate it. And I did take your advice, and I went to the, I sent an email off to the Global Tunnel guy, and I haven't got a response yet that I know of, but we're looking in and getting connected to that also.
Good. I talked to Daryl yesterday, and they're getting a fair amount of activity. I think they're getting up close to 24 connections, and not all of those connections are single nodes. Some of them have, you know, like a half a dozen nodes in the area, and they want to get linked up. So we'll see where that goes.
Okay, thank you. Great
welcome.
presentation.
Oh, you're welcome. Let me see here. Well, this is the Teamtalk interface. Just like your regular FM repeater during the day, there's nobody there. But I hang out here, and you'd be surprised. People will jump in and say hi. I hear from Kevin once in a while and a couple local hams. If you get a Teamtalk server running in your area, I would recommend, if you're sitting in front of your computer, just log in, just like you listen to your local repeater channel. That way somebody will have someone to talk to if they jump on. Let me see here. Let me close that one. Over. Yeah.
Basics FCC question for you. I downloaded the Windows version of Mattermost, and it asked for a server display name. What do I put in there?
I'll send you an invite. Remind me.
Thank you, because I'm already on the Android side already on there, and I communicate with you that way. So now I decide to do the Windows. So appreciate it.
You should. Oh, so you've already got an account.
Yeah.
Let me see here. Oh, that's not what I want. I'm trying to figure out where to find that. Oh. Well, drop me an email and I'll send you the answer. I don't want to tie up the channel.
Not a problem. Appreciate that, Orv. Thank you.
See, you can see the Mattermost here.
Yeah, I can get on the web site on that. I just wanted to see if I can do that on the downloaded software.
Okay. Well, that's not of any interest to you. This other one here is a Slack channel for San Francisco. That's strictly on the internet. I hang out there too. Let me fire up the web browser. Can you guys see my browser?
Yeah, I see your
Yes.
web.
Okay. Oh, we won't go over that. This is my local access point. What I meant to do, let me do this. If you manage a lot of nodes, you want to keep an eye on them. One of the ways to do it is Nagios. It's open source. It's a pain to set up, but it's free and just takes a lot of time to take care of. So I watch that. Over here, this little thing here in the corner, it's probably pretty small on yours, but it's just a little desktop ping application, pinging a couple vital things. That way I can keep them visually in sight. So here, this web page here, I don't know if you can see it well or not, but at every site, we run a Raspberry Pi as a general purpose server. If there's a camera on the site, we do a screenshot every 5 minutes and display it. So you don't have to worry about spinning up a VLC or another video streamer. And because Raspberry Pis have such good I/O, we do some telemetry up at the sites. Down at the bottom, you can see we're monitoring the battery voltage, inside and outside temperature, and AC power status. One of these days, I'm going to cobble up an AC power fail alert and send it over the mesh as an alert. What else? Oh, I don't know. There's another one. Okay, here's a site with 3 cameras. Not because we needed 3 cameras, but because we had a good pan tilt zoom. We retired the older Bullet as an outdoor security camera, and somebody gave me a Junker Dome camera as an internal security camera. So we have all 3. And you can see down at the bottom, there are actually 2 repeater systems in here, 2 separate groups with 2 separate battery stacks, and I monitor their voltages. And because we have a lot of cameras, I pick, it's my home site. That's my Nest Cam. The finches hatched 3 chicks the other day, so we're watching that. So here's a website. I consolidate all of the views all together, so you don't have to jump from site to site. This is on the mesh network, but I also mirror it out to the internet. Just various cameras. A lot of them are replicated. A lot of them are not. But you can see if we have a brush fire coming at us from some direction, we'll be able to keep an eye on it and report it. Weather station, 67 degrees outside. That's really about it. Any other questions? Silence. Okay, guys. Well, thanks for putting up with me going through this the second time. I appreciate your patience. I think we can kill the recording, Kevin.